Hello everybody, my name is Marina Polishchuk. I'm a software engineer at Microsoft Research, and today I will tell you about RESTler, which is a fuzzing tool that we've developed at MSR to help improve the security and reliability of cloud services. So first I'll tell you about why fuzzing cloud services through the REST API is fruitful in terms of finding security issues, how RESTler works. Then we'll go through a demo for getting started by fuzzing a simple REST API with RESTler. I'll then go into the type of bugs that RESTler can find and some challenges in fuzzing cloud services. And time permitting, we'll do another demo of how to do more advanced usage of RESTler for fuzzing real-world REST APIs. So why fuzz cloud services through the REST API? Well, there's been a huge growth of cloud services in the past few years, both in terms of large cloud providers providing more and more capabilities, as well as from applications that typically were not distributed in the cloud, but have been lift and shifted now and often are exposed through REST APIs. And most of these cloud services are programmatically accessible through a REST API, in addition to possibly other methods such as client SDKs and such. And not only public-facing endpoints, but a lot of private APIs today also are implemented through REST, such as through the microservices architecture. And all of these ecosystems are rapidly evolving. So as you can see here, this shows the growth of just the public APIs being tracked in the past few years. And the question we ask ourselves as researchers, developers, and security engineers is, how secure and reliable are all these APIs? So to answer that question, we really need automation to support the scale at which all of these things are growing. So why fuzzing? Well, fuzzing has been used effectively to find security and reliability issues in many different kinds of applications, and it's highly automatable. But how well does it work for REST APIs? So this is what we've been looking at over the past few years, and in this tutorial, we'll share some of our results. You'll see that REST API fuzzing can help find service security and reliability bugs in real services, and that REST API fuzzing can be implemented using RESTler to keep up with the pace of service development and deployment. So our research started in about 2017, and we were mainly motivated by feedback from Microsoft engineers all over the company who were doing security testing for REST APIs. And so the feedback was that existing solutions just weren't finding the issues that needed to be found, and that maintainability was not something that was scalable for all of the APIs that people were trying to support. So some of the solutions that were being used were, one, fuzzing requests in isolation. So you take the endpoints and you just fuzz all of their parameters, and you don't achieve very good coverage that way, though you could still find some bugs in input validation, because that approach doesn't really understand what the service is doing. And the state in which it's trying to fuzz the service is like when no resources have been created, for example. Another approach is to do traffic capture and replay with fuzzing. So for example, run some unit tests or manually use the service and then capture traffic and then fuzz that traffic. So this, of course, depends on how well your service use cases are represented in that traffic. And typically that traffic can be difficult to develop to the full kind of thorough level of coverage that you want to get. And then, of course, for high-value targets, handcrafted custom fuzzers is something that people still write. And this can be very, very effective, but of course, these have a high cost and just isn't a fuzzer that you're going to write and maintain for across all of your APIs. So in summary, the findings were that for large and complex APIs, you really need a different solution that's able to automate more and get deeper into the service. And this is what RESTler provides. Let me show you an example bug that was found by RESTler for motivation. So if you look at this for a few seconds, try to see if you can spot what the bug is. So here we have a client, and we have a service that is a CM service that's creating resources. And so it's creating a resource named X, and we pass it some properties in the body. So here we're fuzzing the val property with 1, 2, star 3. Maybe that's not a valid kind of parameter for that property. And we give it a region, and we get back a 500 error. So this is already a bug, but let's see how much further we can take this bug. So this is an error. So we failed to create the resource, so this resource shouldn't exist. And in fact, when we run a get of all the resources of CM, we get a 200 OK, and there are no resources created for me. But then if you try to create the same resource named X, now with a valid value and in a different region, you get a 409 conflict. So what this means is that X is a zombie resource. So somewhere there's X been created, but we can't see it. And through investigation, we found that it wasn't counted against the user's quota. So an attacker can keep creating as many of them as they want. But this is clearly a resource leak, and it's a potential DOS, both in terms of resources allocated on the backend to for each of these put requests, as well as just sometimes the domain of all the names that is used can get used up. And in this case, it didn't take very long to create this resource. So an attacker could just keep creating these until there are no more names that are available. So to find this bug, you need both valid inputs and invalid inputs. And you need to have these carefully crafted dependent requests that know about a potentially leaked resource and try to abuse that. So to address all of the challenges that I described with fuzzing cloud services, we built RESTler, which is the first stateful REST API fuzzer. So in particular, RESTler only fuzzes a request if all of its prerequisites have been successfully created. And tests are going to be sequences of requests. First, all of the ones that are that need to create resources to run the current requests are executed, and then the current request is fuzzed with whatever fuzzing strategy you specify. And of course, the state space of all of the parameter values and all of the parameter combinations and the request sequence combinations can be pretty huge. So RESTler has some strategies to avoid doing redundant testing. So for example, if you have requests A, B, and C, and a particular ordering of them gave you a 400 status code, then RESTler knows that this ordering with these parameters, well, the service already handles that with a valid error handling response, and we're not going to try that exact sequence again. So RESTler is also automatic. It requires an API specification. So today we use Swagger OpenAPI to generate the fuzzing grammar, which specifies how to fuzz the requests and the dependencies they have. And we found that this is a reasonable thing to ask for because a lot of times the specification is already available since it's maintained as part of the service and used to generate client SDKs. And using the specification, RESTler can provide an automatically good coverage out of the box if the API is well documented. And I'll go into what that means a little bit later. And RESTler is also extensible, so it has pluggable property checkers that the users can also specify additional checkers, such as was this resource leaked, which is the checker that found the bug you saw earlier. So let's see how RESTler works. RESTler has two main components, a compiler and an engine. So the compiler takes an API specification and produces the fuzzing grammar. And this fuzzing grammar has all of the schema information about the requests. It has information about the dependencies, so what resources created by one request are used by another request. And it has code to parse the responses to be able to pass those resource IDs between the requests. The RESTler test engine takes the fuzzing grammar and possibly a custom fuzzing dictionary and some other settings, and it actually runs tests and files bugs. So RESTler has actually several feedback loops for analyzing the responses and the error, the status codes, and based on that, deciding where it should proceed to do more testing. And so it's doing all of this through a systematic state space search. We have several options actually for how thorough you want this search to be. And those result in possibly longer or shorter fuzzing runs, depending on, again, the structure of your API. So here's this very simple example. We have a blog post service. So you can either get or post blog posts, and then you can manipulate a blog post with these 3 additional endpoints. The RESTler compiler produces a grammar, which you can see here. And the grammar says that once you create a blog, you have its ID, which is needed to manipulate it further. And you can see that directly from the paths in this Swagger view. And then the RESTler test engine, like I mentioned, takes that grammar, and then it's just sending sample tests, which are these sequences of requests. So here's what a typical fuzzing session for this demo server looks like with RESTler. One of the things that you should note here is just how many valid status codes there are. So this is unlike other fuzzing tools, which can produce lots and lots of errors and maybe not very much actually valid executions. But here, in order to fuzz a blog post, you need to first create it. So you're going to see a lot of these status code 201s that are, each time they're fresh creating the blog post in order to fuzz it. Here's another view on this fuzzing session. So here you can see that RESTler's test cases, which are sequences of requests, when we increase the sequence length, you get more coverage. Now with this simple example, it's easy to see, but this is still worth, and we ran some experiments to see this coverage on more complicated applications, that it really does increase quite significantly like this as the sequence length grows. So you can view this graph to see what RESTler is doing to get an intuition for it. So sequence length 1, it only runs the requests that have no prerequisites. So in this case, it's getting all the blog posts and creating a blog post. Then with sequence length 2, now it's able to create a blog post, and so now it's going to manipulate it. But it still runs a sequence with one of the requests being the get, for which you don't need any prerequisites. So it is really going through this state space that you have for sequence length 2, and there are more of those. And then for sequence length 3, now it's able to do more interesting things. So the classes of bugs found by RESTler in this slide are actual bugs that RESTler has found. Some of these are going to be bugs that it's designed to find, such as 500 error codes and the security property checker violations that it reports. And some of these are other bugs that are found in the course of using RESTler, or by alerts that fire when you use RESTler on the service that RESTler doesn't have visibility into. So today RESTler is a black box tool, doesn't require any kind of instrumentation, but of course when you run it, you do get the benefit of all of that backend alerting and standard mechanisms that people often have to also detect additional issues that RESTler can find. So one of the first bugs that often is found by RESTler is bugs in the API specification. And the way that you would find these is by compiling the spec, doing the quick start to run the test mode to evaluate coverage. And I'll show you how to do that in the demo. And then you see that your coverage for the service is quite low. So when you get into this, you can see that in some cases the specification, it has under-documented or inconsistently named some of the parameters, and that causes RESTler to not be able to successfully execute requests. RESTler also uses the examples that are provided with the specification, and if these are out of date with the service, then potentially also RESTler with examples will not be able to generate good coverage out of the box. Of course, RESTler has found many bugs in input validation, where it flags all the 500 level 500 status codes. Authentication is an area where RESTler can be used in several ways to find authentication bugs. So one is you can just run RESTler with an invalid token and see what APIs are unauthenticated. And people have found some bugs this way. A more extensive way to test authentication is through the namespace checker, which is actually using 2 different tokens and going through all of that state space and creating resources with 1 token and then trying to access them with the other token to see if some of them are reachable with the one that shouldn't be authorized because they didn't create that resource. And finally, we found one interesting bug with authentication where RESTler, only during its very extensive fuzzing mode, after some amount of time, the service became inaccessible and RESTler essentially stopped working because the authentication script that it runs, it just terminated. And we were investigating this, and it had turned out that this was actually due to a corruption in some backend data structure that is also used by the authentication. So this is one of those unexpected bugs that you can find through fuzzing, where the fix for this bug ended up being a design fix to the API, saying that this code path shouldn't exist. You shouldn't have an update through kind of the data level API that is able to do something to the authentication. RESTler can also be useful to find resource management bugs. So it has found some bugs that were resource exhaustion, which it didn't detect, but were detected on the back end of services, just through its regular execution of creating and deleting resources. And this is a specific type of resource leak that you may want to watch out for when running RESTler. RESTler also has checkers to specifically detect resource leaks, such as the inability to create resources after errors or creating invalid resources. And finally, you can analyze the RESTler network logs to find additional issues that for which there are no checkers today. So as an example, we found some leakage of debug data types just by examining the logs. And then once you know what you're looking for, you could turn that into a checker if you wanted to scale that out to more of your services. So RESTler has been run at Microsoft on many of our services, and it's found hundreds of bugs across the different services so far. And the great news is they've all been fixed or are in the process of being fixed. And with the resource management bugs that it's found, we do warn folks that it's a really good idea to fuzz first in a test environment or a pre-production environment before you do decide to do some RESTler fuzzing in production. All right, I'll next show you how to get started with fuzzing a simple REST API with RESTler. So specifically, we're going to be covering these things. And for those of you who've already cloned the RESTler repo on GitHub and gone through our quick start guide, you will see some of the same concepts covered here. So feel free to skip to the next portion of the slides if you've already done that. So what we're going to be doing is we're going to run quick start to test the REST API from the Swagger specification and generate some config files. And we'll talk about what those config files are, which you can then customize to possibly tune the coverage of your API or add additional values that you want fuzzed. We'll run the compile task to generate a grammar from the API specification, and then we'll run the test task to evaluate the API coverage. Then we'll run the fuzz lean task. So this is the first type of fuzzing that we recommend doing, which basically runs a minimal fuzzing systematic search to cover all of the APIs successfully at least once, and then run the RESTler checkers to fuzz them more extensively. The RESTler checkers that it's going to run are the use after free checker that tries to access resources after they've been deleted, the resource hierarchy checker, which checks that parent-child relationships are enforced in the service, the leakage rule checker, which checks that a resource is not leaked after a failure to create it, and a payload body checker, which fuzzes request bodies. After this, we're going to modify the fuzzing dictionary and then refuzz and see what that looks like. All right, now I'll be switching to the demo. So here I've already cloned the RESTler repo and I've built RESTler. So we can see here in the RESTler drop directory, we have the compiler, the engine, RESTler, which is the top level driver that processes your command line arguments and launches the different RESTler tasks. And results analyzer, which is an ad hoc tool that we have for analyzing the RESTler network logs. What it does is it bucketizes the requests and responses that were sent by the error message text. So it actually tries to group all of these similar error messages, doing some abstraction in the process. And what you can use this for is if, say, your coverage is very low, you can see what are the most frequently occurring errors and try to fix those first and hopefully get the coverage up faster that way. All right, so what I'm next going to do is I'm going to run the quick start on the demo server application. So what the quick start does is it takes just your API specification and it auto-generates all of the other configuration files and everything needed to run RESTler's compile mode to produce a fuzzing grammar and the test mode to try to see what how well RESTler can understand your service and evaluate the coverage. So here we compile the spec, and the test mode tells you that there were 5 out of 6 requests that it was able to successfully run, meaning it got some kind of 200 status code. So this is great. In this case, we can go ahead and just proceed with fuzzing. So let me do this right away, and then we can go look at all of the files that were produced. So what you do to run fuzzing, oops, I had to switch into the RESTler working directory for this. What you do to run fuzzing is you launch the fuzzlean command instead of the test command, passing all the same command line arguments. And now it's actually going to do some fuzzing. In particular, it's going to invoke the RESTler checkers. And you can see here that, hey, we got the same coverage, which is what you would expect, and some bugs were found. So there are 3 seeded bugs in demo server. There's some invalid dynamic object checker issues that were flagged, and there's one 500 that was found by the payload body checker, which is a JSON fuzzer for bodies that RESTler runs. All right, let's see what all of the logs look like so you can get an idea of how to configure RESTler and how to analyze the results. So in the compile directory, you have the fuzzing grammar, and then all of these other config files, which depending on what you need to do for getting raising the coverage, you may or may not ever need to look at. So grammar.py, as we mentioned before, this has information about parsing responses and all of the requests and how to fuzz them. So you can see here there's an enum and a fuzzable integer that are going to be fuzzed, etc. Grammar.json is a JSON representation of the request schema, and this is primarily used for the payload body fuzzer at this point. You have an auto-generated config.json, so if you need to customize this, say if you need to pass several Swagger files or change the custom dictionary file path or any of these options, you know, this already has a bunch of things that were pre-populated for you. Here's the default fuzzing dictionary, so this can be pretty useful. Again, likely you will want to change some of these values for doing more extensive fuzzing. These are just some defaults that we've put in for you. And then similarly, the default engine settings file may have some parameters that you will modify. For example, max combinations tells you that for a particular request, don't do more than 20 parameter combinations at a time. So, you know, if you can afford to fuzz for longer, and you have, like, in some cases we've seen hundreds or even thousands of parameters to cover, you may want to make this value kind of higher. There are also some information about unresolved dependencies. So what this tells you is that there's a parameter page in one of the requests that pages are not created by something else in the API. So if this is completely expected, or if the coverage is high enough, you don't even really need to look at this file. If coverage is low, you may want to first anyway analyze the network logs, but then if you see that, hey, there's a parameter that should have been produced by another API that was passed in, you can look in this file and you can further configure this these values to try to say, for example, that page should be produced by blog posts, and the resource name would be page ID. If I'm just making this up. This is not the case for this particular app, but if that were the scenario, this is how you would configure it. All right. Now let's look at the test directories. So for the test task, the main file that you may want to look at if, say, you have gaps in coverage that you want to analyze is this specconf.json. So this has for every request an entry, and the first thing to look for in this entry is this valid property. So if valid is 0, this means that there was a failure. So there was some kind of 400 or 500 level status code. And you can further investigate this by looking at the error message or at the full sample request. So here you can see that the request body has an ID, which is passed as a string, and the response says that 5869 is not of type integer is the error. So now you would go investigate, like, why is the string being passed? Is it because of an error in the specification, or is actually the specification is correct and maybe there's something wrong in the service, or maybe there's something else going on. And in fuzz lean mode, as well as in regular fuzz mode, you would just get a fuzz directory here. We got some bug buckets, so let's see what those look like. So there's a bug buckets.txt file, which has high-level information about, hey, here's the type of bug. The bug was reproduced. In some cases, we get non-reproducible kind of sporadic issues. So this is helpful to know. And here is the sequence that led to this bug. So this sequence is going to have all of the requests up to the buggy one will be valid. And then this put request here, for some reason, so it's not always clear from the bug bucket, for some reason this failure occurred. So then in the actual details for the bug, by the way, this file can also be passed to RESTler with the replay command, and it will try to reproduce the issue. That's why you have some legend, some characters here at the beginning of these lines. So you can see that there was a blog post created, and then when you ran a put, there was a 500 error for some reason. And again, this put, it kind of looks valid, so it's unclear from just looking at this message and this body what might have gone wrong. This looks like a valid JSON payload. You would have to investigate further with what's actually going on in the service in this case. All right, next we're going to see how to customize the fuzzing dictionary. So I'm going to change the dictionary and introduce a custom payload for the body parameter. So custom payload, remember, means that we're going to specifically fuzz the bodies with these values that I'll provide in the dictionary here. So what you want to do is you'll want to copy the dictionary out of the compile folder, which actually will get overwritten each time you compile. And then you also want to copy the config out of the compile folder, since you'll be changing that. Next, we will see how to update these. So in the config, you'll want to change from the default dictionary to the one where we just copied the dictionary, and in the dictionary, we're going to add a RESTler custom payload for body. And let's give it a couple of values like first blog and second blog. And then if we want to get creative, we can also give it one of these unquoted payloads. Let's give it something like third blog colon D colon 1. So here we're gonna try to inject a parameter. Let's see, third blog ID1. And this needs to be body. There we go. All right, so this is the dictionary. So we've added here a custom payload called body. Unquoted just means that it will use it as a raw string. It won't put quotes around it, while the regular custom payload, it'll take into account whatever type the original parameter was, and it'll quote or not quote it based on that data type. So for example, it'll quote strings, but not integers. All right, let's see what happens when we compile this. So compile, I'm gonna compile the config. And now you can see in the compile directory, when you look at the grammar, it will have an updated RESTler custom payload for the body. 2 of the requests take a body as a parameter, the post and the put, I believe, and both of them will have this RESTler custom payload. Let's see what happens when these payloads are fuzzed. So let's actually first launch test mode. So we're launching test mode. And here we can make sure the updated dictionary is there, although in the grammar now the updated dictionary has been copied there because that's what you listed in the config. So let's see what happens when we test out this new custom payload. And now we can see that, hey, the coverage seems to be now 100%, 6 out of 6 requests. So what happened here? Let's see. See that in the network log. Remember, we had 3 types of blog, the first, the second, and the third. And so what test mode does is it tries to cover each request successfully once. So what that means is if, let's say, there are 3 parameter values for body in this case, this put request that was failing, it will try the first parameter, and then because it failed, it will try the second parameter, and because it failed again, it'll try the third parameter. While if it succeeded the first time, it actually will not try all of those combinations in test mode. It will try them in fuzzing mode, but the purpose of test mode is just to make sure that the basic setup is correct. So it only tries until it finds that first valid payload. So let's see if we have first blog. So here we have first blog, and we had a 201 created, so none of the other values were tried. Let's see where second blog was tried. So here we can see we're actually sending a payload of the second blog. So we sent a first blog, and we received 201 created. This is for the post, and now for the put. We have second blog because the first one we know already failed. The second blog also failed. And now we're going to try third blog. So here is a third blog. And here, this actually succeeded. So what happened here is, if you remember from the earlier spec coverage, we had an error saying that ID is a string and input validation failed. And so here, what we've done is in the custom payload, we've injected this additional ID parameter and we made it an integer. But look, the string ID parameter is still here. And interestingly, the server now accepts this payload, which has these two duplicated ID parameters. So, even though coverage has increased, now RESTler happily can fuzz. This still may be an issue that you might want to take a look at. So you can get some ideas for how you can use these raw custom payloads to run some of these more interesting tests. All right. This concludes the first part of our Getting Started demo. And now let's talk about some of the challenges that arise when fuzzing real-world cloud services. So the first thing you'll probably see that the demo script didn't do is authentication. So for a real-world API, you're going to have to provide some kind of authentication to RESTler, and we support primarily token-based authentication. I'll show you how to do that later in the demo. If you do need some other types of authentication, please talk to us on GitHub, and we'll do our best to support your use case. We do support some other authentication options. You can check them out in the documentation. So the next thing that comes up with cloud service REST APIs is dependencies, both between the requests in the same API specification, or in some cases you need to create resources and they're created by a totally different API. So RESTler has some ways for you to combine different specifications and to specify that, hey, when I run the compiler, I want to have access to all of these different request types so I can properly infer dependencies. But then I only want to fuzz this one resource. So we provide support for you with regular expressions to do that. And another related issue that comes up is about pre-provisioning resources. So typically, if there is some, for example, database that you expect to be available that isn't populated by the API, that will be an issue for RESTler, of course. It knows nothing about it. We hope that other automation that you already have, other testing to support automatically testing the same API can also be leveraged for pre-populating necessary resources for RESTler. But this is something that occasionally, can be a problem that, for example, if you pre-provision resources, but then the API somehow modifies those resources such that they have to be cleaned up every time before executing some of the requests. So we don't provide support for that in RESTler today. If you have that use case, definitely reach out to us again, and we'll try to see what we can do. Naming constraints is another interesting area that comes up in real services. So for example, if you need to create new resources that can only be, at most 10 characters long, the names, or they have to be, some type, they have to be a GUID, for example. RESTler has some support for this. We definitely haven't seen all the possible patterns, but this is an area where often coverage can be low because of something that is API specific and really affects like all the resources in your API. And again, we're happy to support more cases like that as they come up. But a lot of times this type of thing really has to be supported in the tool itself. Resource creation patterns is also a pretty interesting area that we're still exploring and adding support for. So like asynchronously created resources can take a very long time to actually appear. So the question is, should you fuzz that resource like as it's transitioning to being ready? And how long should you wait? And is it reasonable to wait for that resource every time? So RESTler provides an option that allows you to first customize how long you're waiting for such resources, and secondly, decide that, hey, for such resources that are maybe very expensive to create, you're going to actually only create them once and just avoid fuzzing them, and then fuzz them through some other mechanism outside of RESTler, or possibly by using mocks and running RESTler with those mocks and those resources separately. And then another challenging case is rate limited resources, or just resource limits, like I can only create 5 of a resource depending on the type of account that I have. So we have some knobs that you can use to indirectly get this to work in RESTler. But these type of patterns are often difficult to deal with, and with a real service, you may not be able to just turn those off for your testing, but if you can, that would be really kind of the most effective way to at least get all the other parts of the API fuzzed. And there are many other challenges. So, we're actively exploring how to improve the automation in RESTler, improve the coverage that it gets out of the box. And we're very curious to hear from you about what challenges you see. So I'll be switching to my second demo now to show you how to use some of the more advanced features of RESTler that you may require for fuzzing real cloud services. So in the demo, I'm going to show how to set up authentication, how to provide API payload examples, and how to configure custom dependencies when RESTler can't infer them automatically. First, let's see how authentication works in RESTler. So RESTler supports token-based authentication, and we give you 2 command line options that allow you to control how to both get the token for your service, as well as how often to refresh the tokens. So let's see what those look like. Let's say we had the command line for the test mode of demo server, which is the first time that you're going to be trying out your authentication. Here we specified 2 additional parameters. One is token refresh command, and this contains this command line that fetches and prints out the token, and the token refresh interval. So when we ran this on demo server, it looks like it was just ignoring this extra authentication information that we were passing it, because the coverage is still just as good. And let me show you really quickly what actually is printed by this get token command. So here, in this case, there were 2 tokens that we fetched for Alice and Bob, and here they are printed on separate lines. Everything in RESTler except the namespace checker is only going to use one of these tokens, but for the namespace checker, we do check that resources created by Alice then cannot be accessed by Bob. All right, now let's see what this execution looks like in the logs. So here, if you've configured everything correctly, you should see as the first thing in the network log, printed will refresh the token. Here is the command, and here is the new value. And this omitted auth token, this is actually RESTler removing the specific token so they aren't persisted in the logs, just to make it easier to share the logs without having these token values in there. All right. So this is how authentication works. I'll next talk about how to specify example payloads in RESTler. So example payloads are a quick way for you to increase coverage and also just test out what the behavior is for different payloads without doing a lot of manipulation of the dictionary or manually changing the spec or the grammar. So the way that example payloads work is in your compiler configuration, you can specify an additional option called example config file path. And through this option, you will provide some external examples. Now, your specification, your Swagger OpenAPI specification may already have example references that it's using. In which case you may already be getting some of the benefits of examples that I'll talk about in a minute. But this is a way for you to completely override any such examples and say, instead of the example values in the Swagger spec or the schema, use the values and the schema that's provided in these examples. So let's go look at what this example config file looks like. Server config, examples. So here, this mirrors the OpenAPI specification. So you have paths, you have the specific endpoints, then you have the method. And then here you just have, you can give these names, you know, like one. And then you're going to have parameters and then possibly responses. And maybe in the future, we'll put some other things here. So here I've specified that the payload parameter, which is the body for the blog post service, that it's going to have an ID and some tags. Now, if you remember in the schema, there was an ID and then a body parameter. And in fact, in the dictionary, we had some custom payload for this body. Now, the fact that you're using the example here means that RESTler is going to take this and say, okay, what in this example matches my schema? So it still does use the schema in the specification to validate this. And it says, okay, schema has an ID, so I'm going to use ID. The schema doesn't have these tags, so I'm just going to ignore this. And then the body parameter, it's going to say, well, this example didn't have a body parameter, so I'm not going to use a body parameter for the primary search mode of RESTler. I'm going to use it for fuzzing with the payload body checker, which uses always the full schema. But in this case, it's not going to use body to get that initial test run working to make sure that RESTler understands all of the request types. So this can be very helpful if, say, your payload has like hundreds or even 1,000 properties, and but really it's possible to create the resource using just one or two of those properties. You can specify this quickly in an example, and we support both inline ones and as well as a file reference. So this is the examples. We've specified it in the config. We're going to use the same dictionary. So we do need to recompile because, like I mentioned, there's a schema change. And let's see what this is going to look like. Compile, config. All right. So in compile, let's go to the grammar. And let's see here. So in the grammar, you actually see this ID hard-coded to 1, 2, 3, 4, 5, which is exactly the value if you remember from the examples. So this is what it means to use examples. And now let's look at test, just to make sure. So here in test, if you remember, the coverage was before 100%. And now that we've actually recompiled it, we see that, well, this example actually turned out to be not very helpful in this case, and it reduced our coverage. So you get the basic idea. This is how to use examples. In this last demo, let's see how to specify producer-consumer annotations to RESTler. So remember, producer-consumer dependencies are what the RESTler compiler infers to know what sequences of requests to execute in order to create all of the prerequisites for each request that we're trying to cover throughout fuzzing. So here, this Swagger specification for the demo server, this was already pretty high quality because RESTler was able to achieve almost 100% coverage out of the box. So I'm going to rename one of the path parameters here to cause RESTler not to be able to infer producer-consumer dependency. So I'm going to rename this post ID parameter to post. And now RESTler won't be able to infer that when a blog post is created, it returns the ID in the response, and then that ID should be the ID specified in the put, get, and delete requests. So let's run the RESTler compiler and see what happens once this is changed. Let's run compile. And so how would you know that your coverage is not very good? Well, you would have actually run the test mode. In fact, we can do that quickly here to show you how you might investigate that. So you have two options here. You can either, after the compile, look through the grammar and make sure things look okay. This is once you have more experience with RESTler, this is something you can do. Or in most cases, you would just go ahead and look at coverage. So now here the coverage is 50%, which is still reasonable, but we know that we can do a lot better. So let's look at what happened here. So when you go and look at the network logs, you can see that the put actually, we can look at the spec coverage file. This will be a little bit faster. Let's see what the invalid requests were. So the delete failed, the get failed, and the put failed. Let's look at the put request. And it looks like we're getting an error message that's not even JSON. And the request body looks pretty good here. And the request URI, however, now has this strange looking ID. So maybe this is what's causing the problem. So let's look at why that ID is being passed here. So we can look at the grammar. And we can see that here, the grammar contains the ID dynamic variable that corresponds to the post creating the blog. And this is indicated by the writer. So this is the producer part of the producer consumer dependency. But when we look at the put request, we see that what's plugged in here isn't that ID. You would see a reader if that were the case, but it's this custom payload UUID4 suffix. So what this means is it means that RESTler now thinks that put is also creating blog posts, which in this case is not correct, and most likely the service doesn't accept just this arbitrary ID for the put, and it's returning some error. So let's see how we can work around this if, let's say, you were not the one maintaining the Swagger specification and couldn't necessarily update the names there to improve it right away, but wanted to fuzz with RESTler. So what we're going to do is create a producer consumer annotation. The quickest way to do that is to go to this dependencies.json file and find the request in question. So we have the put request, and then find the path parameters. So here there's just one path parameter, and this is what the producer consumer annotation looks like. So here you can see there's no producer endpoint and method, and RESTler thought that a new resource is being created, so just gave it a producer resource name. And we're going to put this into an annotations.json file. So this is our template, and then of course modify it so that it's actually does what we need. So consumer param is the post. The producer resource name, this is the name of the property that comes from the response. The producer method in this case is post. And then blog posts is the endpoint. And then we also need to make sure that the config is updated with the path for the annotations. Looks like it's not there yet. Annotation file path. We specify the path to these annotations. And now let's recompile and see what happens. Actually, we can go ahead and retest as well. So when you've recompiled, now when you look at the grammar, the same blog post ID, we can search for reader. And now all of these delete, put, and get now all correctly have the ID that's received from the response of the post. And then test is also back to our good coverage number that we wanted. All right, this concludes the demo. For finding more information about how RESTler works under the covers, Please look at some of our research papers. So we have 4 publications linked below in the slide. And our GitHub documentation also has a lot of details that can help you get started fuzzing your REST APIs. Thank you so much for attending this webinar. And please give us feedback, as well as I'm happy to stay around for Q&A afterwards, and I'll see you there in a few minutes.
Thank you, everyone, for attending this webinar and live Q&A. So I'm Marina Polishchuk. Over the next 15 minutes or so, we're going to be answering the questions submitted by the audience. So let's get started. So thanks for all of you who've already submitted some questions. Please keep them coming. I'll start with a question that is kind of related to one of the questions that was asked here about, are all the bugs that we find always fixed? So, one thing you may wonder is, can RESTler report false positives? So the answer is, it depends on your API. In most cases, we do not see false positives, but it's possible that with some of the checkers and with how you've designed your API, that you may see some bugs reported by RESTler that you may choose not to fix. So before that, for any error, you may see some bugs being reproducible and some not. And as I mentioned in the talk, RESTler does try its best to reproduce a couple of times and report to you whether or not it was reproducible. An example of a false positive would be for its namespace checker when it's checking different authorizations. Sometimes services, if you query for a resource that you're not authorized to view, they will return to you like an empty list of resources with a 200 status code, while RESTler is expecting you to return, a 404 or some error status code saying that, really you've done something that you shouldn't access. So this is an example where if your service is designed like that, then the way that you would get rid of those false positives for your service is you would go and modify the namespace checker just to handle that particular case. And all the checkers have a specific API that you can use to basically exclude cases that are by design in your API. All right, it looks like we have a new question come in. Let's see. Does RESTler cover security vulnerabilities in API endpoints such as the OWASP top 10? Okay, thank you. That's a great question. So RESTler, actually, we started this project in 2017, and this was before this great list of the OWASP API top 10 came out. So specifically, where RESTler is most relevant is going to be for testing REST APIs. And a bunch of those RESTler does cover. So I won't have a chance to go through them in detail as part of this Q&A, but that's certainly something we can add to our FAQ. And one thing to call out is that there are, there's some checks, like, for example, SQL injection, that RESTler does not include out of the box. And this is because there are already other great tools that exist to test for those. So one possibility for some of these checks that RESTler doesn't cover would be also to use RESTler to generate the traffic, because RESTler is great at taking an API specification and getting deeply into the service in terms of coverage. And then you could send that traffic and use that in conjunction with the other tools that are out there for testing SQL injections to inject those specific payloads. Okay, great. It looks like there's another question that just came in. Question about producer-consumer dependency. How do you include an ID created by one endpoint in the payload of a consuming endpoint? Right. So this is showed a little bit of that in the demo. The way that you do that is through these annotations. And so specifically, you refer either by name or by JSON path to one ID. This is your producer, and the other ID, which is your consumer. So the one ID is going to come from the response, and the second one is going to be the one specified to a request. And we have some documentation on GitHub for how to do that, but we should provide pretty complete kind of hooks for you to do that in terms of what you can express as part of the Swagger schema or OpenAPI schema. Awesome. Another question that I was thinking would be good to cover that we didn't talk about is, you may wonder, like, how long does it take to run RESTler? So if I want to run RESTler as part of my CI/CD pipeline, or just do like a very thorough kind of fuzzing run on a regular basis, like how long would that take? And so of course, that's going to largely depend on how many requests, like how large your API is, and then also how long it takes just to query the service. So RESTler itself typically isn't the performance bottleneck in the testing that we've done, where you're going out to query some cloud service that's deployed elsewhere. It's not like all done on the same machine. So for a very complex service with a couple hundred requests with very complicated bodies, etc., we've seen test mode, which is just this initial mode to see what requests are covered. It can take half an hour to an hour. And then once you get into these fuzzing modes like fuzz lean, where you're running the checkers, if you have very complicated bodies, this can take up to like 12 hours or more. But there are a lot of knobs that you can turn on and off to budget your fuzzing. So for example, RESTler by default will have all combinations of parameters up to a certain bound, and you can try to increase or decrease that bound. And the checkers individually, likewise, you can turn checkers on and off, and then the checkers also have a bound. And then another thing that RESTler allows you to do is use regular expressions to restrict even which requests you're testing. So say if you wanted to include this in CI/CD, and you have some kind of a change kind of notification that you're able to give RESTler to say, hey, I actually only changed the code that's associated with this one API. Certainly you could do that in the case of specification changes pretty easily. Then you can tell RESTler to like really only fuzz that API and its dependencies, and it'll figure all of that out for you. All right, cool. There's some new questions that just came in. Let's see. How can we identify uniquely requests generated from the RESTler tool so that if the proxy firewall has to whitelist such requests, it can do that? So RESTler does send a specific header which you can use. I don't remember specifically what is all included in that header. I believe it's like RESTler and then the version. So that's definitely that definitely should be possible. Let's see. Does RESTler support fuzzing JSON documents based on a JSON schema? Have you found interesting classes of bugs presented solely via the HTTP request bodies? So the answer is yes and yes. And actually in the resources section, there should be a link to our FSC 2020 paper where we have some case studies that are specifically for fuzzing the payload bodies, which are sent as JSON. So we had to kind of address that problem and design a JSON fuzzer that's both taking the schema into account as well as the fuzzed values. And for the latter, we have some feedback-directed kind of fuzzing, which you may be familiar with from other types of fuzzing. So we have a form of coverage guided fuzzing where we use the error code and error message as sort of an indicator of how well we're exercising, all the error handling code that's associated with these different JSON schema variants and the different values that we've assigned. And I would say in terms of the type of bugs that we have been found, that we found, and a lot of those have been, basically input validation type bugs. It's been so far the largest generator of bugs in terms of what RESTler is able to find. So it does find lots of different, lots of issues. And I think, the one interesting thing here also has been that we've seen that these bodies don't always match like what's in the specification. So sometimes this fuzzer actually is able to find like valid bodies that don't correspond to the specification just because it's trying all these variations of JSON. So it's been kind of interesting to look at some of that data. All right, cool. Hope that answers the question. And you can also reach us on GitHub for more data on this specific checker. Also, can the requests be rate limited? Let's say only 10 to 20 requests per minute. Yes. So there's a delay that you can specify. I believe it's in the engine settings. And then there's also a delay that you can specify only for resources being created. That'll basically help you address rate limiting type issues. The more difficult issue that we don't handle super well right now is the case where the resources are there's a hard resource limit. Say you can create 5 resources only of this type, because the algorithm kind of expects you create some resources and then asynchronously you're cleaning them up, and as long as it's within reasonable time, there's no specific count of resources that we're trying to adhere to. So that's one issue that you may run into, but as far as like a kind of timing-based rate limiting, should be able to handle that. Let's see. Is schema validation a subset of this fuzz testing? So today it is not a subset of this fuzz testing. Again, there's some other tools that exist for validating schema against requests, but this is a pretty popular kind of a request that we've heard, so we may add this in the future. Cool. Thank you for all the great questions. Let's see. One other thing that might be good to mention is what's like a typical use case for RESTler today that we've seen, because they do tend to quite vary. So initially when we started, we definitely thought about a lot of it as this much more automated way to do strong security testing for APIs. And so that is still one use case where people basically want to fuzz the heck out of their API. They have a specification, and this allows you to achieve like pretty good coverage out of the box. So you can still kind of get a read on the quality that way, even without a lot of upfront work writing a grammar and such. Another use case we've seen is where there's just like one specific security checker that people are really interested in, possibly modifying, the security checkers that we have to add their own or to extend one of ours. And this can be pretty powerful. Like you can apply that to all of your APIs in your organization that has a certain class of bug that maybe is not included in RESTler out of the box to check for. And then another kind of, large use case that we've seen recently is this case of using RESTler for regression or differential testing. Like, for example, if you have your service deployed in many different regions and you just want to make sure that they're always consistent, they're offering the same experience. So you baseline, and then you basically just make sure that their differential testing isn't producing you any new diffs on a daily basis. All right. Great. Any more questions from the audience at this point? All right, thank you all for attending today. We appreciate your participation and interest in the topic of improving cloud service security and reliability by fuzzing REST APIs. So if you're interested in learning more, we have listed some resources in the resource list to the right of your screen, including our GitHub repo and some of our publications. And we really look forward to seeing how you build on this research. We hope the tool will be useful to you if you're facing the problem of testing cloud services through the REST API. And please let us know what you think. Please continue to interact with us on GitHub after this talk. Thanks again for attending, and have a great day.